Hello everyone. So in the last video we rotated the array to the right side by k steps. So in this video we will rotate the array to the left side. The process is simple and it is same as the previous one, just that we will get the different output. Okay, let's understand the problem on the paper first. Okay, so let's take the similar problem as yesterday's in the previous video, which is 1 2 3 4 5. What was the question? Complete question. The question was root. So we had an array nums 1 2 3 4. So our input array had the elements 1 2 3 4 5 6 7, and k value is 3, which is we have to rotate the array three times, right? So this is our initial array, and after rotating for the first, so in first rotation what we are going to do is we will be moving all the elements to the left side. So to move all the elements, how can we move the these elements one by one to these positions? So we can run a loop and we'll move and we will iterate through the array, and then one by one we can shift the elements, and we will shift this first element to the last position, right? So here what we are going to do is, in the first step we'll run the loop for loop. We'll start the pointer from 0th index, and then we'll run the loop till nums length nums dot length minus 1, and we'll increment by 1. We'll move the pointer by 1. Then what? So we are going to assign this nums dot I value. This nums of I will become nums of I plus 1, right? So this is nums of I, and we are assigning nums of I value of nums of I plus 1. So this is how it's going to this is how we are going to assign we are going to move all the elements to the left side. So this will become 2, this will become 3, this will become 4, this will become 5, this will become 6, this will become 7. Now this will remain 7, right? But if we, so before moving all these elements, we have to temporarily store this 0th index, so that we can then after moving all these elements we can move move the first element to the last position. So what we will do here is we will temporarily store the first element in a so nums of 0, we will store the nums of 0 in the temporary variable called as first element. Then once all the elements are shifted to the left side, we will then put the element nums dot length minus 1 is equals to first element. So once we moved all the elements to the left side, then at the last position we will move our first element, right, equal to k minus 1, or we can take it as k because our index starts at 0. So if in the question it is given as 3 k is equals to 3, then we can put the loop condition as less than int I is equal, we'll start the from 0th index and we'll run the loop till I is less than k, because I will at k is equals to 2, when I is equals to 2, our array will be rotated 3 times. Then I plus plus will increment by 1. Then so first, before moving all these elements to the left side, first we will store the first element in the temporary variable. So nums of 0. Okay. Now in we will and so what we are doing in every rotation is we first we are temporarily storing the element in the first element, and then we are moving all the elements to the left side. So we can run a loop from 0 to nums dot length minus 1, and then we'll increment our pointer. Now this is nums of I, so what it will become, nums of I will become nums of I plus 1, so and so forth. So nums of I will become nums of I plus 1, right? So once once all the elements are shifted to the left side, then we will place our first element at the last. Then nums of nums dot length minus 1 will become first element, right? So this will be our code. So in the first rotation, our array will become 2 3 4 5 6 7 1. In second rotation, our array will become 3 4 5 6 7 1 2, and in third rotation our array will become 4 5 6 7 1 2 3. So this will be our final array. So and the time complexity of this brute force approach will be n into k. N is the total array length, and k is the number of rotations. So that many times, so k times we have to perform the operation of shifting all the elements to the left side. Now let's write the code. So our program will start executing from this one public static void main, and we'll initialize our array in nums array is 1 2 3 4 5 6 7. This is the value, and k is equals to 0, right? Now we will call the function rotate array, pass nums and k, and finally we will print the nums array. Okay, so now let's define the function public void rotate array. This is taking nums as arguments, nums and k, right? So what we are doing here is, first we are running a for loop till I is less than k times, and then we will be storing the first element temporarily, so that after moving all the elements to the left side, we will place the first element at the last position, and we'll run another loop to move all the elements to the left side. So nums of I will become nums of j will become nums of j plus 1. And after moving all the elements to the left side, we will then finally place the nums first element at the last position. Nums of length minus 1 will become first element, right? All good. Let's now run the program. So what my okay, so this is the string representation of an array. So to print array, we will use the method arrays dot to string, then it will print the nums array. So this is nothing but basic this is the hash code of the object array object. We did not save the program. So we got the array value, which is 4 5 6 7 1 2 3, which is our output. So here we were getting 4 5 6 7 1 2 3. So we got our output, right? Now, so the time complexity is n into k. K is time rotation, number of rotations into into the length of an array. So now let's try to solve this problem with optimal approach using the reverse method. So what we will do here is we will just remove all this and we'll put it as reverse method. We'll give the name this function as reverse, and then we'll pass the array, and then we will also pass starting position and the ending position from where to where we have to rotate the reverse the array. Okay, then we can first let's see on the paper what we can do here is. So this is so our final so this was our initial array. In the first step, we reversed the complete array, so it became 7 6 5 4 3 2 1. And in the second step, what we did was we reversed the array from zeroth index to the k minus 1, which was k minus 1 is 3 minus 1 2 till zeroth index 0 1 2, right? 0 1 2. So it became 5 6 7 4 3 2 1. Then in the final step, what we did, we reversed the array from k to n minus 1, which is nums length minus 1. So it became 5 6 7 1 2 3 4. So this was rotating array to the right side. But if we do the same if we apply the same method as we did in the string rotation to the right, we are not getting the our desired result, which is 4 5 6 7 1 2 3. We are getting some other. So let's try the combinations. Let's try. So in rotating array to the left side, what we can do here is just shuffle these steps in, shuffle the steps 1 2. This is first step, this is second, and this is third. So what we will do here is we will just shuffle these steps and we will get the answer. Okay, so first we will reverse from 0 to k minus 1. What it will become? Our array will become, so this is our initial array. So when we reverse the array from 0 to k minus 1, where k value is k is 3, so 0 to minus k minus will be 2, k minus 1 will be 2. So this is 0th index, this is 1 2 3 4 5 6, right? So in the first step our array will become, in the first step of reversing, our array will become something like this: 3 2 1 4 5 6 7. In second step what we will do, we will reverse from k to n minus 1, then it will become 3 2 1 7 6 7 6 5 4, and in final step we will reverse the complete array. It will become something like this: 4 5 6 7 1 2 3. We got our result, right? Now let's write the code. So reverse function, we will send start. So we'll run reverse the array, we will run a while loop, and we will run it as long as start is less than end, and we'll use the temp variable to store the nums of start. We'll swap the elements, and then after swapping we will just move the start pointer by 1, and then we will decrement the end pointer by minus, right? So here first we will reverse from, we will reverse nums from 0 to k minus 1. In the second we will reverse from k to n minus 1, and in the final step we will reverse the complete array. Okay, so we did not define the n value, so n is equals to num dot length. we got the final answer. So the time complexity for this optimal solution is O of n, and the space complexity is O of constant. See you in the next video.